this is project deliverable number 5, which is our project proposal presentation. I'm Allie Beesing.
I'm Marcus Carrillo.
I'm Charles Usler.
And I'm Rachel Yan.
So in this presentation, we are going to go over our problem definition and requirements, our proposed design, our justification, and then finally end with our conclusion. Starting off, the problem definition and requirements. Engineers are the core of easing life. What if they could be mobile in order to help and teach on the go?
So our problem statement is that Engineers Without Borders needs a solar-powered vehicle so that we can get engineers to all these places where they're needed. So we're going to make a solar-powered vehicle so that it can reliably rely off the sun without worrying about power or anything else or fuel. And it's going to be very rugged. It's going to be able to traverse in hard environments. Therefore, it can go wherever it's needed.
Hi. So these are our design requirements and criteria for the solar-powered vehicle. So firstly, we have to follow a $80 million budget. It had to run on solar power alone. There had to be automation for the purpose of passenger safety. It has to traverse long distances, aka 20 miles, over rugged terrain, fit in the on-site garages, transport at least 3 people, and have more than one function, so versatility. This is our AHP table for our weighted criteria. And we concluded that we should prioritize low cost followed by durability and versatility. And a low cost design allows for maximum efficient use of resources and materials while leaving enough funds to perform regular maintenance and repair on the vehicle.
Hi, this is our proposed design. So far we designed 4 vehicles, and this is the one that won. We put it through our decision matrix. So our design is a van-shaped like vehicle. Up here we have the heart of the vehicle. It contains our Arduino board, breadboard, and all kinds of wires. We also have a workbench that folds up to the wall, so it's like a Murphy bed. And here's a 3-dimensional picture of the interior of our vehicle. On the top of the vehicle, towards the front, we have a excess storage. So, anything that we could put on top of it, we can do that. We also have underneath storage because we kind of base this around a tour bus, so we wanted to include that. And over here, we also have our motor. So what makes our design unique is really just the heart of the vehicle. And we also wanted to make it, durable and versatile. So here are our schematic design for the vehicle. So we have an ultrasonic sensor, and we also have the solar panel going to the motor to, move the vehiable.
As for the budget, right now we were given $80 million, and right now we're sitting at $54.9 million. So we are well below budget. We have all of our individual expenses listed here. And we want this low cost and we want this low budget because we want to have a lot of flexibility for anything in the future. So like we were saying, it gives a lot of money for flexibility in the future and extra space for essentials.
So we put all of our designs into a decision matrix and weighed them against each other according to our criteria. And our selected design ended up being the one that maximizes storage on the vehicle while minimizing costs.
So here we have the idealized versions of our design. So, the ideal, functionality of our solar panel, the motor, and how bright it is going to be outside. So we are prioritizing low cost and durability. The low cost really just allows us to have more flexibility with adding anything extra to our design.
And from those costs, one of those things that we measured was lumens, which we found that a larger solar panel will have more lumens collected, therefore more energy. And we also found from some of our data that we collected that a higher gear ratio will allow more speed. So we're going to implement both of those in our final project. On top of that, even including those, we still have low design costs, which is great for what we're going for, and it has plenty of workspace for everything to work with. Our design is very functional when it comes to cost as well as design space.
As mentioned before, our design is very low cost, versatile, and durable, let alone it's a very innovative design in comparison to a lot of the designs that are out there for solar powered vehicles. Not only that, but we added in some aesthetically pleasing properties, such as the fact that it is pink. Now, going back to the other designs, this is a no-no.
And our two main sources of inspiration for our vehicle design were tour buses, as mentioned before, the really large, very spacious, and the underneath storage. And we also took ultrasonic sensors as our inspiration since, modern cars usually have some sort of a distance sensor that tells you, how close you are to something and alerts you when you're getting too close to something.
In conclusion, we hope that this is a satisfactory vehicle design, which we think that it is. We also think that this design meets the criteria that we listed. As said multiple times before, this design is very innovative, durable, and versatile, in addition to being low cost. So, based on those criteria, this is truly the best possible design that we could think of. And in the near future, we intend to further revise our code to make it perform the things that we want it to do. Call to action for all of you guys. We need to find more sustainable methods of production and transportation because the current state of the earth is less than ideal. And if we want to continue to prosper and live comfortably, we need to take action now. This is why the Magenta Machine is an important asset to humanitarian efforts and organizations so that we can help those in need in remote locations without contributing to the demise of the earth. Thank you for your time. Make sure you follow us. This is our lovely Instagram. As you can see, we have many followers, so follow us. Here are references. Thank you.